Black holes, they are, without a doubt, one of the strangest, most mind-bending things in the entire universe. They're like these cosmic monsters that seem to defy all common sense. So let's follow their entire story, their cosmic biography, from a ridiculously violent birth to an impossibly slow death. And really, when you think about it, it all comes down to two huge questions, doesn't it? First, where in the world do these things even come from? And of course, the big one, the one we've all secretly wondered about. What would actually happen if you fell into one? To find the answer, our story actually begins not with a death, but with the life of a truly, truly massive star. So, for most of its life, a star is locked in this perfect cosmic tug of war. Deep in its core, you've got nuclear fusion creating this incredible outward blast of energy. And fighting against that is the star's own immense gravity, trying to crush everything inward. For millions, sometimes billions of years, these two forces are in a perfect, delicate balance. But for the biggest stars out there, that balance is doomed. Eventually, the star's fusion assembly line starts producing iron. And here's the problem. Unlike all the elements that came before it, fusing iron creates zero new energy. The furnace at the heart of the star just goes out. And in that instant, the tug-of-war is over. Gravity wins, and it wins catastrophically. The core implodes at a staggering quarter of the speed of light, triggering a massive supernova explosion that blasts all the heavier elements out into the cosmos. So the crucial point is what's left behind after all that chaos. You either get a super dense object called a neutron star, or if that original star was a real giant, the core just keeps collapsing forever into what we're here to talk about, a black hole. So now we have our black hole. But what is it exactly? Let's break down its anatomy. First, you've got the event horizon. You can think of this as its surface, the boundary that we can actually detect. It's not a physical thing you could touch, though. It is the point of no return. Why? Because the gravity there is so strong that to get away, you'd have to travel faster than the speed of light. And since that's impossible, nothing ever gets out. Right at the very center, you find the singularity. Now try to wrap your head around this. This is where all the mass of that collapsed star is crushed into a single point with zero volume and infinite density. And the honest truth, we don't really know what it is. Our laws of physics just completely break down when they try to describe it. I love this analogy because it just nails the problem perfectly. A singularity is where our understanding of the universe basically returns an error message. It's a physical does not compute. And hey, before we move on, let's bust a huge myth. Black holes are not cosmic vacuum cleaners. They don't just go around sucking things up. Their gravity is just like any other objects. If our sun was suddenly replaced by a black hole of the exact same mass, you know what would happen to Earth? We'd just keep orbiting it like nothing happened. I mean, yeah, we'd all freeze to death, but we'd be in a perfectly stable orbit. All right, with the basics covered, let's get to the main event. What happens when you actually encounter one of these things up close? Okay, let's imagine you are a very unlucky astronaut and your ship is on a collision course. What is your journey actually going to look and feel like? This is where things get truly bizarre because reality itself literally splits in two. To your friends watching from a safe distance, you'd appear to slow way, way down as you approach the event horizon. You'd get redder and dimmer, and eventually, you'd seem to freeze in place forever before just fading away. But for you, from your perspective, you'd watch the entire future of the universe flash before your eyes. Once you cross that event horizon, your fate is sealed. And this analogy just illustrates why perfectly. Space itself is so warped that all possible directions, forward, back, up, down, they all point to just one place, the singularity. There is no turning back. There is no standing still. The only way is inward. So what happens at the end of that one-way street? Well, physicists have two main theories, and spoiler alert, neither is great. The first one is called spaghettification. The pull of gravity on your feet would be so much stronger than on your head that you would literally be stretched like taffy, torn apart into a thin stream of atoms. The other idea is the firewall, where you just slam into a wall of high-energy particles right at the event horizon and be vaporized in an instant. Now, how quickly you meet your end really depends on the size of the black hole. If it's a smaller, stellar mass one, the gravitational forces are so extreme, you'd be spaghettified before you even cross the event horizon. But for a supermassive one, the gravity is actually more gentle at the edge. You could fly across the event horizon completely intact and probably survive for quite a while inside. And when we say supermassive, we really mean it. The largest one we know of, a beast called S50014 plus 81, has the mass of 40 billion suns. Its diameter is 47 times the distance from the sun to Pluto. It's a scale that it's almost impossible to properly comprehend. That even these cosmic titans, these absolute monsters, don't last forever. They have a life story, and that means they also have an ending, even if it takes an unimaginable amount of time to get there. The key to a black hole's death is a process called Hawking radiation. It's a truly bizarre quantum effect that proves that even black holes can't hold on to their energy forever. It allows them to slowly, very slowly, shrink and evaporate over timescales that are just staggering. So, how does this even work? Well, it turns out empty space is constantly fizzing with pairs of virtual particles that pop into existence and then instantly cancel each other out. But if a pair happens to appear right on the edge of the event horizon, one particle can fall in while the other escapes. That escaped particle becomes real, and it carries away a tiny speck of the black hole's energy with it, causing the black hole to shrink just a tiny, tiny bit. Now, this process is incredibly slow at first, but it speeds up as the black hole gets smaller. By the time it shrinks to the mass of an asteroid, it's radiating heat at about room temperature. At the mass of a mountain, it's as hot as our sun. And then, in its very last second of life, it evaporates in a final massive explosion, releasing the energy of billions of nuclear bombs all at once. But just how long does all this take for a supermassive black hole? The estimated time is a Google years. That is a 1 followed by 100 zeros. It's a number so large that the entire age of our universe so far wouldn't even register as a blip on that timeline. And this is the final, pretty sobering chapter. By the time the last black hole finally radiates away into nothing, there will be nothing left to see it. All the stars will have burned out long, long ago, leaving the universe cold, dark, and empty. The death of the very last black hole truly signals the end of the cosmos itself.